Hi, everybody. Thanks for joining the 11th data catch-up session by Kaggle Days Meetup Delhi NCR. We hope you all are staying safe and doing well. Today we have Bruno. He would be talking about optimizing the underwriting with survival analysis. He is a PhD in mathematics by University of São Paulo and is a lead data scientist at Datarisk. We are definitely very happy to host you, Bruno, today, and too much interested about your topic which you are talking about, like how data science and this data domain could be used to help with this domain or with this financial aspect of the things, right? So over to you, Bruno, and we hope this session is really useful for the community members.
Okay, thank you very much. First of all, thank you for the invitation. It's a pleasure to me to be here today, and it's a pleasure to talk about this topic and to say something that things that we are doing and what we are trying and testing in this topic and in this field. So, talking a little bit about me. As you said, I'm a PhD in mathematics by the University of São Paulo, and actually right now I'm a lead data science at Datarisk. So if you, after this meeting, someone has some inquiries, some doubts, or just want to connect, you can send me an email. And to say about Datarisk and what we are doing, we are in Datarisk. We are a technology company, and right now we are solving problems of the industry using artificial intelligence. So, artificial intelligence. So every problem that you can find in the industry, we can solve right now using this. So I have here some examples of things that we are doing right now. So we have a lot of clients, a lot of problems of them of demand planning. We have some models and some clients that we are doing models to increase the sales. So we identify good clients and who will buy the products of the company. We have fraud detection models. So it's a lot. We have a lot of projects in the financial industry about this. And the topic that I will talk today, that credit models, it's really common. We have a lot of projects in this field in our company, and we have a lot of different things to do. So different, how can I say, problems trying to solve, how to give loans to clients, so how to identify good clients. So right now, today I will talk to you about something that we are trying to do, that we have a project that we did this, that is use survivor analysis to optimize the underwriting of a new product. So I will explain this a bit. So that's the idea today. During this presentation, I will talk about a little things. So I will give a little bit of the definition what we are considering today a credit score, and what is a credit or a loan that a company could give. I will say a little bit about classical targets. So how industry try to solve these problems nowadays, and what is common to use, and how we can change a little bit this and use a survivor analysis to solve this kind of problem. And in the end, I will give it to you an example that we really did, and compare things and say how the survivor analysis model was compared to the classical models. So what is a credit score? So let's imagine that you have a company. So it could be a company, a retail company, or a bank. And a client asks for credit. And here credit has a how can I say, is a really wide range of interpretation. A credit could be you give money to your client to use for something. So someone goes to the bank and asks for money, but it could be a product too. So if you want to buy a product and you go to a retail company, to a retail store, and you say, okay, I want to buy this phone or this television. That company, that retail store, could give you the credit in the form of the product. So they can give you the product, and you will pay for them in installments in the next months. So this kind of things are credit too. And when a company, for example, if you have a company and you are selling your products to other companies or to your clients, or to imagine that you have a company that how can I imagine? You have a product and you sell your product to supermarkets and things like this and the supermarkets sell the product to the clients. So when you give the product to the other company, it's a kind of credit too. So we have a wide range of things that we can consider. Consider a credit, and in the biggest problem here is how can we decide who is a good client and who is a bad client. So when a client arrives in the company and asks for the loan, how can we decide who is good and who is bad, to approve and to reject? The main idea here is that we can build a model, we can train a model to identify this kind of thing. So imagining a machine learning model, we can do this thing. Okay, we can define what is a good and a bad client for the company. That part is really important. It will be the target of our model. And what is a good and bad client? It depends on the company, depends on the business, depends on how you receive money, how you give money. So this part is really important to understand. And I will talk a little bit about this today. And then in the rest is the basic idea is the same. Then you build any machine learning model. You gather historical data of the clients and information of the clients. So you have all the information about age, address, education, previous loans, things like that. You gather this kind of information, and then you can create a model to indicate who is a bad or a good client. So you will be constructing a classification model to identify this. So in a very simple way to think, you have to create the target. So you have to define what is a bad and a good client. You have to train a classification model and evaluate this and see, okay, if I use my model to give a loan, to give money to my clients, what is the what I have in the end? I'm losing money. I'm okay. I'm receiving money. So it's really important to understand this. And how this thing is done today. Imagine that you have, for example, a company, for example, a retail store, and you sell your products, and a client can go to your company and ask us for credit to buy some products. Okay, I want to buy a telephone or a cell phone. I go to the company, I say, okay, I want to buy this cell phone, and then they can give to you the credit, saying, okay, here is the cell phone, and you have to pay me the cell phone in 10 installments of this price. And you you pick the cell phone, go to your house, and in the next 10 months you have to do the payments. So how is the classical way that we identify a good and a bad client? We identify this creating these classical targets that I call here ever XX mob y. The idea here is that in the XX, in the first part, I have a number of days that I can, how can I say, accept a late payment. And in the last part, I have the period of time I will consider. So let's give you an example. Here in the middle, I have a person that bought a product and he has 8 payments. And we have the first payment in November of 2020. He paid on time. In December, on time. January of this year, he paid, but 15 days later. And then in February, 35 days later. In March, okay. Then April and May, he paid it. He paid in late again. And in June, he paid on time. So I have here annotated how much days, how much of late days they did the late payment. So what we can define here is if I can look for the number of days and the period of time. So if I consider at 8 months, so mob 8, I will use all the 8 months, all the 8 payments that they have. And if I consider, for example, XX to be 60, what I say if in one of these payments he did a late payment with more than 60 days, he will be a bad client. If all the payments during this period we have payments on time, or payments that the late payment is less than 60 days, it's a good client. Why we do this? Because sometimes if someone have a late payment, it's not a problem to the company. You can have that some person will not pay in the correct date. They will pay 20, 25 days later, but they will pay. And sometimes they pay this with some tax together. So it's not a bad thing. What we try to identify with this kind of behavior is the clients that takes a lot of time to pay and maybe never pay again, because that's the real problem in the most of cases to the company. So here we can define what is a good and a bad client based on this kind of behavior. For example, I have in the second line an example. If I consider instead of 60 days of late payments, 45 days for late payment, I would have that this same client would be a bad client. So to define how to use or which which number we use, so which target we use, we always look to how the company works, or how this product works. So we have to understand how much time the companies can accept a late payment, and it will not have a huge influence in the company. It will not be bad for them. I have here another example with shorter periods of time. For this same client, if I look, for example, 45 days in 3 months, if I consider the last 3 months, in the last 3 months, considering 45 days, they don't have any payment higher than, he don't have any late payment higher than 45 days. So it will be a good client. So, but if I consider 6 months, he will be a bad client, because I have here that in the last 6 months, one of the payment he did with more than 45 days. So it's a bad client for them. So that's the classical. This is the classical target that we use on credit models, on classic credit models. So the idea here is that we have to consider two things. So how much days we can accept a late payment, and it will not affect the company, or not affect the behavior, and how much time, how much months or installments in this case we should consider, because we can if we have that almost all the products have a small number of installments, you don't need to consider a huge amount of time. But sometimes you have that this payment can be done in 24 installments, things like that. So you have to consider a bigger period of time. But this is the classical target that we use today. And what happens is that depends on the month that the client asks for the loan, or asks for the product. We have different period, different information for the client. So clients that bought the product in November of the last year, I have information of 7 payments of them. So I can say how is the behavior of these clients in 7 months. If I look to a client that bought the product in February, I just have 4 months of information, because he paid, he has to pay the installments from March, April, February, March, April, June, and July. So I have just 4 months of information for them. And this kind of thing is difficult to you. This kind of thing leads us to a point that if you have a product that is, if you have a company, a product that will have a lot of information. So, for example, for 2 years you are given loans and things like that, you can use this kind of information, because you can pick a client from the last year and construct the targets for them, and do a model to identify who is a good and bad client. But imagine that you have a new product. So your new product, you launched it in January of this year. So you have just 5 months of data for some clients. So you have just a small amount of data to try to train a model, or to try to decide who is a good and a bad client. I have here example. If we decided that for the company, it's important to look for 3 months to understand if it's a good or bad client. So if I try to train a model in this kind of situation, I can use clients just for these 5 months. So I can use just clients for November, December, January, February, March to train the model. So all the clients that ask us for a product in the last 3 months, I will not use in the train. I will not use to construct a model. For example, for my company, I decided that 6 months is the ideal period of time that we should consider to decide if a client is a good or bad client. I have less data, because I can use just data from the last year, because I can use just data from November, December to train a model. So this kind of targets has this this problem. We need time to construct the targets and to use to train the model to identify things. And it's really bad when you have a recent product, or when you have a product that you are seeing that the behavior of our client, or the type of client that's asking for a product or for a loan is changing, because you can use just data from a lot of time before to train, and you are seeing that in the last 3 months you have a different behavior, things like that. So this is the classical targets that that we use in credit models, thinking classical in a classical approach. So we have some pros of this kind of situation, because this kind of target and this kind of models, they tend to be more stable, because you consider a lot of time to construct and to see what is a good client or no. It's widely used, so a lot of companies use this. So when you ask and when you start to talk about this with new product with the company, a lot of people know how to do this, and you have a lot of literature to support this. So that's the pros of this kind of approach. But the cons is that you need time to gather the data. So we needed to wait to start to train the models. And as I said, it's really hard to identify a change in behavior of the client. Because if I see that in the last 2 months, the client of my company is changing the behavior, but to my models, I use a target that is ever 16 mob 8, I will not see these clients for the next 6 months. So it's really difficult to identify this kind of change with the model. So what is the idea here? The idea is to use techniques and models from survivor analysis to try to how can I say, to avoid this kind of problem. So I put here a model that we use to this, that is Cox proportional hazards. This model is a type of regression model that is typically used in survivor analysis in medicine. So this kind of model, they appeared trying to understand if a treatment will be efficient to avoid a death or avoid complications in a disease. So because of this, we call it survivor analysis. And this kind of model, it has a mathematical expression like that. So here, T represents the time, so the survivor time, so 1 month, 2 months, 3 months. H of X and T is the hazard function determined by the covariates X. So imagine that X here is the covariates of the person. So age, sex, type of medicine they are using, things like that. So H will be the hazard function. So how is in some way how likely this person will die, or things like that, we have the impact of the covariates. They are measured by the coefficients beta. We have beta 1 to beta n. They are multiplying each of the covariates in this regression model. And we have that the term H0 is called the baseline hazard. It's something that if you don't have none of the coverage, what would happen or what you would expect to happen. So if you have if you don't use some medicine, some things like that, what do you expect to be the hazard for that person in that time? So that's what we call baseline hazard. And the idea here is that if we look for the second part of the expression, it will be time independent. We have that we have t just in the first part, in the h0. In the second part, we just have the exponential of the multiplication of the covariates by the coefficients. So what happens is that if I look to two persons in this kind of model, for example, I have a person X and a person X X line. If I try to understand the hazard of them during the time, if I look at every point of time, for example, if I have XX, HX for the first person, HX line for the second person. If I consider every time the same time and compare them, we have that when we divided one expression for the other, we just have the second part here because the baseline hazard is the same for both of them. So in some way, what we are saying is that if in the beginning of the treatment, thinking the survivor analysis, if someone has twice the probability to die than the other person, it will happen all the time. All the months, they will also have twice this probability to death. So this gives to us that when we do this kind of approach in survivor models, the second part is independent of time. It just depends of the person. And because of that, we can use these parts of the equation of the Cox proportional hazards model to construct a credit score. Because this second part here, it will be a number between 0 and it can increases because it is greater than 0 because it's an exponential of something. But when we use a classification model to try to say, okay, what is the probability of this person to be a good or a bad client, we need a number between 0 and 1 because what we use is that this probability. So what happens is that since the second part doesn't depend on time, it just depends on the person, we can use this second part to how can I say, to change the scale and transform this in a probability. So we use the second part, and we can use one thing called empirical cumulative density function, ECDF, to change the scale of this thing and transform these parts of the equation in a number between 0 and 1. So, for example, we have the XGBoost, the package, the model. It has an implementation of Cox regression models. You can put as the algorithm there, Cox survivor, and then the result of this model in the XGBoost will be just this part here that we have highlighted in red. So we have just the exponential of the coefficients multiplied by the covariates. So using XGBoost, we can train a Cox regression model, and the result will be this second part here. We can separate a small part of our data set to construct empirical cumulative density functions. The idea here is that we will look of the results of all these of the model of the, or how can I say? We will look to this number for all individuals in this separated set, and we will construct a density function. So it will be from 0 to 1, and they will see how they are, how can I say, how they're accumulating. So because of that, we have that the result of the model composed with this function results in a number between 0 and 1. And using this thing, we can construct a score for this client. So here I just have 1 minus ECDF composed with the result of the model, because we are training the model to say, okay, how is the probability of this person to be a bad client or to death? And doing this, we are just inverting the line, is to say, okay, a person with a credit score close to 0 is a bad person, a bad client, and a person with a number closest to 1,000 is a good client. So that's the idea of how we use a Cox proportional hazard model to construct a credit score model. And the idea here is that I was saying that we use this kind of model to try to identify if a person will die or not. But the idea here is that we can change this to put this in the context of a loan of the installments, for example. So imagine in the survivor model, in the class in Cox proportional hazards, you think that we have months to a person die. To transform this kind of thing into approach to credit models, we change this to look for the person and see how much months they need to have a late payment. So, for example, if I'm a client, I buy a product and I have a late payment in the 4th installment, I will say that in the 4th month, I have a late payment. I have how can I say the same thing that in the survivor analysis was the death. So we can do this kind of thing to adapt the interpretation of the survivor model to the credit model. So instead of look how many months a client will a patient will need till he dies, we will see how many months some client needs to a late payment. And because of this, we can use this kind of data, so this kind of model to construct a score. So the idea here is that when we use this kind of model, Cox proportional hazards, what we need to annotate to everyone is things like that. For example, here I have four clients. I have the client 1. He bought some product in January of this year. The product needed to be paid in 3 installments, and he paid all the installments on time. So we have that in February, May, March, and April, they paid the product with no late payments. So for this person, I annotated 3 because the installments ended. So we have 3 months, and he paid it everything okay. And I don't censor this line because I know what is the result of this client. I know that he paid it all the loan or all the products with no problems. For the second person here, I have that a person bought a product in December of the last years. He had 6 installments, so January, February, and in April, May and June. But in April, he did a late payment. So I know that in the fourth month, he had a late payment. So I mark that in the fourth month, he had a late payment, so he died. And I say that I don't need to censor this data because I know what is the result of this client. I know that in 4 months, he is a bad client because he had a late payment. For this other client, the client number 3, I had that he bought a product in February. He has 6 installments to pay, and right now he has paid everything on time, but just 4 of these installments because as he bought in February, right now we are in July, and we don't see the last 2 installments because he has to pay this yet. It will be this month and in the next month. So I say that this client, he has 4 payments, okay, but I say that I have to censor this line in the meaning that I don't know the result of this client yet. I don't know if it will pay all the installments on time or not. So here I have a client that paid the first line, a client that paid all installments on time. So I put this and I don't censor the line. In the second line, I say that a client has a late payment on the 4th month, and I don't censor that because I know the result of this client. He is a bad client. And in the third line, I put that this client has 4 months that he is paying, but I don't know the result of this client. So I put here that I need to censor this data. This kind of information is what we need to use in the Cox proportional hazards model. So the difference here is that instead of look just for a small period of time, so some months, with this kind of model, we can use all the clients because someone that entered in our base, so someone that bought a product in May, for example, I can put that on the model because if it has 6 payments, for example, and he is paying on time, I will put that he paid the first one on time, but I have to censor this line. But for example, for clients that just in the first month already has a late payment, I put the information that he has a late payment and I don't censor this data because I say that this client is bad. So we can use all the information that is entering in our database to train the model. So this is really, really good for products that you don't have a lot of data in your database, or products that you are seeing that the behavior of our client are changing really fast. For example, if you have a product, if you have a retail company that is located in some part of the country, and then you open a retail company in another part of the country, and the behavior of the kind of the behavior of people buying in this new retail is different from the other because they are from the different regions. Maybe the amount of money people receive in each region is different, things like that. We can identify that, and we can use in the training of the model because we can use we can use all the data that we have already in the model. So to use survivor analysis or this kind of survivor target, it is really good because we can identify this quickly change of behaviors of our clients, and it is attracting more attention in the last years. So comparing to the classical targets, survivor targets and survivor analysis for credit score has less literature to support. I don't say that they don't have literature to support. You can find some texts, some books explaining how to use this kind of model to credit score, but compared to the classical targets, we have much less literature. But the good thing is that it is attracting more attention in the last years. So we are seeing a lot of companies trying to use this and trying to adapt the way of thinking to use this kind of model to make the decision to give a loan or not. And I put here that I think I will not enter in details, but we have a difference in how we evaluate how a classical model is doing, and how good is a classical model, and how good is a model using survivor analysis. In classical models, we use mainly the Kolmogorov-Smirnov test, KS, and we have the AUC, area under the rock curve. For survivor analysis, we use this index that we call the concordance index. In some ways, when we are training a survivor model, we are trying to identify how much time a person needs to become a bad client or to die, things like that. And in some, what the concordance index do, they see two persons, and they say, okay, I know that this person has a late payment in the fifth month, and this other person has a late payment in the third month. So this person, the first person, should have a hazard ratio, a hazard greater than the second, because he has a late payment before. So what the concordance index do is that they look to the result of the model for all those persons, and they compare the result and say, okay, the hazard of the first one is greater than the hazard of the second. So the model is doing good here because he is given a higher hazard to a person that will have a late payment before. And the concordance index, they look for every pair of clients or in the database, and they compare how much the model gives, how many times the models give the right answer. So they give a higher hazard to a person that would have a late payment before than the other. So we look for this kind of comparisons, and we say the proportion of that. So this is the way how we start to evaluate the model. And the idea here, I just bring a small framework of how we can use for survivor analysis to construct a credit score to a new product. So imagine that you have a new product, so you have, 3 months of data. What you can do, you can use these 3 months of data to build a survivor target, and then you construct a model, you do the optimization and things like that we already do in machine learning models, but using this index, the CI, the concordance index, to maximize this index. And then you look for the metrics. So you separate a small set and look how is the result of the model in this set. And then what is really good to see, that what is a thing that we do in our project is that since the companies, they know the classical targets, we do this using survivor analysis and the concordance index to evaluate the metrics of the model. But we also construct really small classical targets. So ever XX mob 1, ever XX mob 2. We have to wait some time to construct this, but for everyone that we can do this, we evaluate the model in these small targets to see how the model is going and how is the stability. And using this, we can every month update the model. So we can do this in a frequently way, really often actually. And we can update the model with all the data that we have and see how the model is doing during the time. So if it is stable or not. And this kind of thing is what we use to convince the companies or the clients that okay, we have a good model here. We can test this thing and see if it is if it will be good in real clients and how to use. I have here a small example of a project that we did. We have a retail company that sold products, and they needed to know how much they need to separate which clients should receive a loan, so should buy the product and receive a loan to pay the products in the next months. Because they had a different product, because they had stores, but right now they are doing this online. But the behavior of the clients online is really different from the clients from the in real retail stores. So what we did with them was that we trained some models using survivor analysis, considering the first model that we did. We used 4 months. That was the data that they had at that time, and with the time we started to add the new months to the training. So here we have 2 models that we built and we trained to them. The first one we trained with 4 months, so from July to October of the last year. And the second one we trained with 6 months, from July to December of the last year. And we compared the result of these models in the first 3 months of this year. Here I have how much clients they had in each, approximately how much clients they had in each month. So we had that before this year, they were just testing the product, so they have a small amount of clients each month. And this year they started to open the products to a wider public. So we have a lot of information now, and we have that comparing these models. We have that we could give to them a product that had a model, actually 2 models that had a better behavior, a better way to separate good and bad clients than the old models that they have using classical targets. So with just 4 months and using a survivor target, we could almost double the metrics of their first model. And with 2 more months, we could add a lot of how can I say, we could give to them a better model just with 2 more months to train. So right now we are trying to understand the new clients and bring more data to train these models. And we are thinking in the 3rd version of this, but we already see that we have a really good model here compared with the techniques that we had before. That's it. I think that we have the minutes for questions, but that's all for today.
Yeah, thank you so much, Bruno, for such an awesome talk on the credit scoring and the various aspects of that domain. Because usually a lot of folks know these things like from the top only, like what's credit score and like what are the related installment terminologies and kind of things. But today you definitely explored, helped us to explore the depth of the things, right? And like a lot of insights from there. And like we had a question, like though you covered it very well, but still, like in case you would love to any point in case you would love to add any pointers to this question that's coming up on the screen, like the thing that you mentioned, like mob yy and that like the parameters that you told. So yeah,
Mhm.
any additional pointers or anything that you want to share from your real like real industry experience around that.
Okay. To determine how would be a good number, or how type of target we should use, what we do is that one thing that we like to do is to make a graph looking uh, how much people pay compared with with months. So, for example, I look for all the installments and I see how what's the proportion of person that pays with one day of late payments, 2 days of late payments, 3 days, and I do a graph for this. And what we use in a lot of cases is that we can understand the behavior of the clients, because we looking for this kind of curve. We can identify, for example, things like, okay, there are persons that forget to pay the installment, so they will pay the installment, they will remember to pay the installment third day later, because they will see the next installment and say, okay, I didn't pay the previous one, so they pay these together. So a lot of things that we saw is that doing this kind of graph, we see how is the behavior of the clients, and what is the highest number of the highest number of days of late payment that we can have people paying, or a good quantity of people paying. And after that day, we have the, okay, after this day, no one's pay, almost no one pays. So we use this kind of thing to determine, okay, let's use it 30 days or 45 days or 15 days, depending of the product. Another thing that we do is that we look we look uh, based in each month, how is the proportion of clients in that month that never paid the product. So, for example, I look, okay, people that paid the first month, that didn't pay the first month, how much of them paid the other installments? And we will do this proportion to each months, and we can look for things like that. For example, with the first graph, we can decide how much days we use. With the second analysis, we can decide how much months we will use. For example, if I see that in the 60 people that didn't pay something in the first 6 months, things like that, and 95% of the persons in this situation don't pay more, okay, I can use a small target, because I say that, okay, 90 after 6 months, see if someone didn't pay, he will not pay anymore. So I can, because 95% of person in this kind of this situation didn't pay. So we can use this combination of analysis to determine, for example, how much months and how many days we will use.
Yeah, got it. So that's a like framed answer with the help of analysis and data visualization, right? So thanks to touch on that. Another question that one of our community members had, it was like this credit scoring industry is kind of regulated ones, right? Like in any country, it's not that like you cannot take risk, like otherwise you would be losing revenue or you would be losing customers. That like you are wrongly predicting that this is a bad client, or you are wrongly predicting a bad client as a good client, like the concept of those false positives and those concepts. So like from a regulation perspective, these things definitely play a huge role in in the production of machine learning systems into financial domains, right? Like let's say any government have certain central banks, and they would not appreciate if your model is doing like it's predicting something wrong which it should not do, or it's a black box kind
Mhm.
of model. So like how do you see the regulations and the regulatory aspect of this credit scoring?
Okay, that's a really good question. There is something that it's really interesting to you to say about this kind of model. For example, survivor and analysis models in this kind of industry, because as I show it to you, we have the expression. So we have the coefficients, and we have the cover rates. So for each variable, we can explain how much that variable is affecting the model. So this kind of model, it's really good for that, because it has a really simple explanation of saying, okay, you didn't receive a loan, or you didn't receive the product because this variable here has a huge impact in your score. So it's really easy to explain for the client, and for the government, and to explain why you are doing this. Here in Brazil, we have we have to be able to explain why I didn't give a credit for some person. So if someone didn't receive a loan, we have to explain, okay, why you didn't receive the loan, and what we use it to do this kind of decision. So I think it's really, I think it's, we have to consider this. I think it's really good to avoid things like prejudice and things like that. And for this kind of models, regression models, it's really easier to explain. If we use a survivor analysis model, or logistic regression model, we can explain that. And what we are doing right now, and it's working really well, is trying to use new kinds of interpretation of machine learning models, things like Shapley values and things like that, to try to bring this kind of interpretation and try to understand why the model is doing those kind of decisions. But I think it's really important, and it's really important to discuss things like to avoid. I think that the biggest thing, avoid prejudice. So avoid this kind of pre-build thing. So
Yeah.
I think it's really good.
Yeah, thank you. So like a last question, to keep to be considerate of the attendees time too. So it's like we have seen a lot of alternative data sources coming into picture, right? Like how you behave on social media, or like certain user human behaviors that we have, that are being taken into consideration these days by certain applications or certain organizations to generate a better, or like as much accurate credit score you can talk about. So like how are your views about art, like alternative datas, and like what's the potential of them, and where do we see like a breakthrough coming with the help of these alternative data points for credit scoring?
Okay, that no, that's really interesting, and we are trying to use every alternative data that we can find to do this. And one thing that we think it's important, and we try to understand before to use, is that if the alternative data has something related with the product or with the company, things like that. For example, for a retail store, alternative data about the things like how people use credit cards on supermarkets and things like that maybe make sense. So we are trying to use things like that, things that are interesting to use too, that we are testing and doing projects using that, is to use, for example, the location of the house of the person. So we can use the exact location and try to do a score based on the region, and use this kind of score as a how can I say, as a variable on the model. Try to use, for example, that's a project that we can find some tests in the blog of our company. We use it images of the Google Earth to see the image of the house of the person, and to use this, we use it some neural nets to transform the image in some variables, and use that variables in the model. So I think we have a lot of opportunities here, and changing the clients or changing the product, we can use different things. So I think it's really important to use, really important to test this, and we are doing this, so it's really really cool.
Yeah. Got it. Got it. So thanks, Bruno, for joining us today and like helping us understand this domain better and to answer the questions that a lot of folks have from this community. Thanks to you and thanks to the attendees for joining. Stay safe and bye bye.
Bye bye.